Assalamu alaikum. Today I am presenting a demo class on 555 timer and how a 555 timer can work as a stable multivibrator. So let's see. An stable multivibrator, sometimes it is called free running multivibrator, is a multivibrator which has no stable states. It has two states but both are unstable. Let's focus on the block diagram of 555 timer. Here we see that inside a 555 timer it has three equal resistance, two comparator, one flip-flop and two transistor. The truth table is shown in below. We use those three conditions for a stable operation. Here the circuit diagram of 555 timer as an stable multivibrator is shown. Here we see that two resistor which is externally connected with 555 timer and one capacitor C is connected. Now an interesting thing is the negative terminal of comparator 1 is 2/3 VCC and the positive terminal of comparator 2 is 1/3 VCC, which is always a constant value. We can change those constant voltage by applying any voltage in the pin 5, and that's why pin 5 is called the controlled voltage operation. Let us assume that previous output of flip-flop is 1. So as flip-flop Q is 1, that means Q bar is 0. As Q bar is 0, that means T1 transistor is off. So now capacitor is charging through this path. Here yellow path is shown. Capacitor is charging this path. Now as capacitor is charging, the capacitor voltage Vc is increasing. When it increases up to 2/3 VCC, that means when it crosses the 2/3 VCC, the positive terminal of comparator 1 will be 1. That means the output of comparator 1 will be 1 and the flip-flop get a reset signal. So as the flip-flop get the reset signal, flip-flop output Q will be 0. Here Q will be 0 is shown. When Q is 0, Q bar is 1. As Q bar is 1, T1 transistor is shorted. So now the capacitor is discharging through this path. Here yellow path is shown. That means the capacitor voltage Vc is decreasing now. When the capacitor voltage is below 1/3 VCC, that means the positive terminal of comparator 2 will be higher. That means the output of comparator 2 will be 1. So the flip-flop get a set signal. So again the flip-flop set the output Q1. Here again Q output is 1. So capacitor is charging through again this path. So in this way capacitor is charging and discharging continuously, and the output of flip-flop Q is 1 and 0. We can call it high and low. Here the output of flip-flop is shown. Now capacitor voltage Vc always 1/3 VCC to 2/3 VCC. By applying the condition we get this T high equation, and similarly we get the T low equation. Cycle is the ratio between T high to totality of any signal, digital signal actually. Now to get in this equation we never get the duty cycle below 50%. To get 50% duty cycle we just set RA and RB. In this way we can make and a stable multivibrator by 555 timer. Thank you.